Chapter 11 is a big change from the previous couple of chapters. So if you were struggling with 9 and 10, this might be a break for you and kind of get a bit of a fresh start. So we're going to talk about gases. And I get the idea that the author of the book, Navaldo Tro, has an affection for orange soda, which probably rivals my affection for sugar-free Rockstar Punched. But he talks a lot about orange soda throughout the book. And one of the things he talks about at the beginning of this chapter is going to restaurants as a kid and putting straws together. And I think if you didn't do that, you watched other kids did that and wished you could, right? But your mom wouldn't let you. So you take a whole bunch of those drinking straws and you stick them into each other and you try to make an extra long straw. And maybe set your cup down on the floor and drink through the straw. And it's really cool. He says he even sometimes would take duct tape with him to a restaurant so he could make the seal tighter with the tape. He must have had tolerant parents. Have you ever wondered why a straw works in the first place? We all use them, but how does that work? You're sucking on a straw and the liquid comes up. I think we're also accustomed to straws working the way they do, that we don't even really think about how does that work? Well, what happens is that when you suck on a straw, you're removing some of the molecules from inside the straw. Sorry. Well, I guess we're going to be red now. And that creates a pressure difference between the inside and the outside of the straw. So if you put a straw in a liquid, the liquid comes up to the same level inside the straw as outside, right? It doesn't just come squirting out of the straw into your mouth. It just sits there because the pressure inside and outside is the same. When you suck on the straw, you're removing the air that's above the liquid, and that creates a pressure difference. There's a pressure outside. It's called atmospheric pressure. When the pressure goes down on the inside, then the outside pressure forces the liquid up the straw and into your mouth. So it's actually the atmosphere that is pushing the soda up the straw. How long could you make a straw? Could you make one that's infinitely long? Could we make one that would allow us to stand on the second floor up here on the science building and have a cup of soda down here on the mezzanine and drink through it that way? Some people saying, yeah-ish, probably. That'd be kind of interesting to try. You wouldn't be able to do it with cheap plastic straws from McDonald's because the walls are too thin. And when you created enough suction, it would actually collapse. That's what always happens when I drink milkshakes from Jack in the Box, right? The milkshake is too thick and the straw is too flimsy, and so you suck on it and it just goes flat. But if we had a nice, maybe a stainless steel one, how tall could we make it? It turns out there's a limit. There's a very definite limit to how far you can get that to work. And it's about 10.3 meters or 34 feet. Beyond 34 feet, you can have the most powerful vacuum pump in the world. You can pull a perfect vacuum on that, and you can't get the liquid up any higher than 34 feet. Does that seem a bit arbitrary? We'll see why. Well, what is pressure anyway? Pressure is the force exerted by something per unit area. So for gases, it's the force exerted per unit area as they collide with the surfaces. So here we have an illustration of gas molecules. And the gas molecules are zooming around. Well, they run into things. And when they run into things, they exert a pressure. At Earth, at sea level, and we're not much above sea level here in Fresno, the gas molecules exert a pressure on average of 101,325 newtons per square meter. Okay, that sounds like a really big number, right? It's just a very small unit. That is equivalent to 14.7 pounds per square inch, which we often refer to as PSI. P stands for pounds, and SI stands for square inch. So pounds per square inch is the same as PSI. So 14.7 pounds per square inch. That is the pressure that the air, right now as you're sitting here, is putting on your skin and all over you. And we don't feel it because we are accustomed to that. One of the dangers of, going in outer space, among many other dangers, is if you're not wearing a pressurized suit and you step outside of the spaceship, if you have air in your lungs, it's going to get sucked out. The air in your cells is going to expand, and all sorts of nasty things could happen. We have developed to live in a situation where we have pressure. So, the straw in the drinking glass. So here's the straw, empty straw, open to the end. You stick it in, and the soda rises to the same level as outside. The pressure inside the straw is equal to the pressure outside, the atmospheric pressure. When you suck on the straw, you lower the pressure inside. The pressure outside stays the same. The outside pressure being greater than the inside pressure will force the liquid up the straw. So, if we had a perfect vacuum, here's a nice vacuum pump, and we're sucking all the air out of this rigid tube, we could only get the orange soda to come up 10.3 meters. Because atmospheric pressure is 14.7 pounds per square inch, but there's also pressure exerted in a downward direction by gravity on this orange soda. And when you get to the point where that pressure equals this pressure, it's not going to go any higher. And it turns out for things that are mostly water, that's about 10.3 meters or 34 feet. Yes?
And that doesn't matter, whether it's the size of the straw or anything?
That's a good question. It doesn't matter what size the straw is. You might think, well, if the straw was a larger diameter, then it would be different, right? But it isn't, because it's pounds per square inch. And so it depends on the area, but it also so if you change the area, the pressure is still the same, because you're changing the square inches, but then the force will also change. Any questions? Now, you've heard, it's a little different talking to you guys than talking to people in Reedley. You've heard about the drought, though, right? And how the water table's going down. And lots of people that live out in the country are experiencing dry wells. The water table is going down, and so their well doesn't bring up water anymore. So last semester I had a student ask me, and I didn't immediately have a good answer for this, but I thought about it and then I figured it out. Well, how does a well work then? Because a lot of these wells they're drilling are like 200 feet deep. How does that work? You can't have the pump at the top of the ground and pull water up. You can only do that for 32 feet. So what do? They put the pump down in the bottom and they push the water up. So the well has to be big enough that they can lower the pump down. Of course, they don't want the pump in the water, but they lower the pump, and that's how they get the water out. So any questions about straws and orange soda? So before we build a straw for the second floor, we should measure it. I kind of think it's more than 34 feet. It's just not going to work.